So this differential equation, again, is called a second order differential equation because it involves a second derivative. You're not going to see this actually in your homework until chapter 4, but you do similar problems like this now in chapter 1 that are first order, involving just a first derivative. So the concept of this equation and the solution and how to find the solution like this still comes up in chapter 1. And it is a matter of just, well, hoping that this kind of thing works. It should make some intuitive sense that this kind of thing would work, because we're after a function whose second derivative plus 5 times its first derivative plus 6 times the function always equals cosine of 2t, no matter what t is. So some function like this should seem like it would be a good guess. It is an educated guess, but then you have to actually do the calculation to verify it. Take the derivative. You get negative 2a sine 2t plus 2b cos 2t for the first derivative. Take the second derivative. Get negative 4a cos 2t, right? We're getting an extra factor of 2 each time. Minus 4b sine 2t. Plug those things now into the left-hand side of the differential equation and plug the function in right there. Simplify. The best way to simplify is to group together the terms involving cos 2t together and the terms involving sine 2t together with some coefficients in front that involve a and b. Set it equal to cosine of 2t no matter what t is, and you get a system of 2 linear equations in a and b you've got to solve. What are the terms that involve cos 2t? It would be this one, and this one, multiplied by appropriate constants, 1, 5, and 6. This one gets multiplied by 1, so you get a negative 4a times 1 is negative 4a. This one gets multiplied by 5, so you get 5 times 2b is 10b. And this one gets multiplied by 6, so you get a plus 6a. That also simplifies to 2a plus 10b. That gets multiplied by cos 2t. For the term involving sine 2t, you got a negative 4b from right there, the y double prime. A 5 times negative 2a is negative 10a. Oops. And then a 6 times b is plus 6b, so that's a plus sign, not a parenthesis there. All that simplifies to negative 10a plus 2b, and that gets multiplied by sine 2t. Does that look good to people? No mistakes? You're setting that all equal to this, no matter what t is. The only way that's going to work is if this, the coefficient of cos 2t, equals 1, and this, the coefficient of sine 2t, equals 0. So there's your system of linear equations to solve for a and b. I'll do it quick with technology. I've been using calculators, but let's use Mathematica. Couple ways you could do it. You could do solve, capital S, square brackets. Put curly braces inside there and type your equations. 2a plus 10b equals 1. When you solve equations in Mathematica, you've got to use double equal signs. If you use single equal signs, it's going to mess it all up. That's the most common mistake here. Use double equal signs when solving equations. Negative 10a plus 2b, double equal sign equals 0. Then after the curly brace, put a comma and another curly brace. And inside there, put a comma b. You're solving for a and b. There's 1/52 and 5/52. Did you get that? Okay, so the final answer for your solution here is y equals 1/52 cos 2t plus 5/52 sine 2t. That's what you should have gotten. That is one function, one solution of this differential equation. But wait a minute. All the differential equations we've had so far have had infinitely many solutions with arbitrary constants. Why are we just getting one solution here? Well, it's because we set it up that way. We were looking for one solution. We were looking for constants A and B that made this work. There are more solutions, we just haven't found them. How do you find the other solutions? This is relevant for chapter 1. You can consider an associated homogeneous equation. Here's a connection to linear algebra. This is a non-homogeneous equation because your right-hand side of this equation is non-zero. Just like non-homogeneous linear equations and linear algebra have right-hand side numbers, at least one of which is non-zero. And it's helpful sometimes with thinking about kernels and relating it to solutions of non-homogeneous equations to think about, well, what would happen if I made that a zero? That would be an associated homogeneous equation, not the same as the original equation. Homogeneous, if I can spell here, equation y double prime plus 5y prime plus 6y equals 0. This is a different equation, a different differential equation than the original. But it turns out, and this is relevant again for chapter 1, if I can find the general solution of this equation, like finding the kernel of a linear transformation, adding the general solution to this particular solution will give me the general solution of the original non-homogeneous equation. I'll say that again. This is really, really important. This is relevant for your homework. If I can find a general solution of this associated homogeneous equation where the right-hand side is 0, how do you do such a thing with the second order equation? It is a matter of guessing. You actually guess y equals e to the s times t, where s is an unknown constant to solve for. And such a guess turns out to work. It turns out here in this example. If you can find a general solution involving some arbitrary constants that can be anything, 2 arbitrary constants for a second order equation, 1 for a first order equation, added to this particular solution of the original equation, you'll get a general solution of the original that you can use to solve initial value problems as well. I'm not going to show you the details, but that is something you'll do. And yes, finding a general solution to this is like finding a kernel of a linear transformation. Very, very much analogous in ways we will make more precise later as well. This is an important model in physics. It's a harmonic oscillator model. Applies to masses on springs, applies to electric circuits in electronics. What do the constants represent? I'll leave that for later. For mass on a spring, they're related to the mass, the spring, and the damping friction. With a electric circuit, I don't know, it's related to capacitance and resistance and things like that. I took electronics from Beacon, but I don't really remember anything. That was like 34 years ago. So yeah, I was a Beacon student 34 years ago. I think it was the second time he taught electronics. And he really liked my lab reports. I did really nice lab reports. But because I did such nice lab reports, I was slow. I was also slow at doing the experiments. So I didn't do enough labs to get an A. So at the end, I was like an A minus. I'm like, sorry, I want to leave for Christmas. He's like, you can do a couple more labs and get an A. No, I want to leave for Christmas. Question? I think so. Yeah. But I wrote my reports by hand. Can you imagine? I mean, I could have tried typing them to some degree, but there would have been whiteout and things like that. And then I like making my graphs and my pictures by hand too, but oh well. I should look. I probably have my reports somewhere in my office, but I don't know where.